Okay, so actually, so modulation allows us to transmit or allows the transmission to occur at high frequency, while it simultaneously allows the carrying of the message signal. So, according to this overview, modulation can be defined. It is the changing characteristics of the carrier signal with respect to the instantaneous change in message signal. Okay, or in simple way, it is the process of mixing a low energy message signal with the high energy carrier signal to produce a new high energy signal which carries information to a long distance. Okay, so in this process, in modulation process, changing of characteristics like amplitude or frequency or phase of the carrier signal, it will be changed in accordance with the amplitude of the message signal. Okay, and the device which is used to perform this modulation is called the modulator. Okay, so here on the next slide, like suppose this is your message signal. Okay, this is low frequency signal, and it is mixed with this carrier signal, so that at the receiving end we can get this type of signal with high frequency. Okay, so this is your message signal, this is your carrier signal, both are modulated, and we can get as this signal at the receiving end. Okay, so why we need this modulation? So there are certain reasons. Now, what are the reasons? First one is to avoid mixing of signals. Now, this one of so basic challenges. One of these basic challenges facing by communication engineers is transmitting individual messages simultaneously over a single communication channel. A method by which many signals or multiple signals can be combined into one signal and transmitted over a single communication channel is called multiplexing. Okay, so multiplexing, all of you are familiar with this term, multiplexing. So we know that the sound frequency range is within 20 hertz to 20 kilohertz. Okay, now if the multiple baseband sound signals of same frequency range, that is from 20 hertz to 20 kilohertz, are combined into one signal, and it is transmitted over a single communication channel without doing modulation, what happened? All the signals get mixed together, and the receiver cannot separate them from each other. We can easily overcome this type of problem by using the modulation technique. Okay, so by using the modulation technique, the baseband sound signals of same frequency range, those are within 20 hertz to 20 kilohertz, are shifted to different frequency ranges, and therefore now each signal has its own frequency range within the total bandwidth. And after modulation, what happens? This the multiple signals having different frequency ranges can be easily transmitted over a single communication channel without any mixing, and at the receiver side they can be easily separated. Okay, they can be easily identified. Okay, the second point is to increase the range of communication. The energy of a wave depends upon its frequency. Now, the greater the frequency of the wave, the greater the energy processed by it. Okay, the baseband audio signals frequencies, these are very low frequency, so they cannot be transmitted over long distances. On the other hand, the carrier signal is a high frequency or high energy signal. Now, therefore, the carrier signal can travel large distances if radiated directly into the space. The only practical solution to transmit the baseband signal to a large distance is by mixing the lower energy baseband signal with the higher energy carrier signal. And when the lower frequency or lower energy baseband signal is mixed with the higher frequency or higher energy carrier signal, the resultant signal frequency will be shifted from lower frequency to higher frequency. Hence, it becomes possible to transmit information over long distances. Therefore, the range of communication can be increased in this way. Okay. Third point is for wireless communication purpose. Okay, in radio communication, what happened? The signal is radiated directly into space. Now the baseband signals, so those are in this range, like 20 hertz to 20 kilohertz. It is not possible to radiate baseband signals directly into space because of its poor signal strength. However, what I meant by using this type of modulation technique, any modulation technique can be used so that the frequency of the baseband signal is shifted from the lower frequency to higher frequency, and therefore after modulation the signal can be directly radiated into the space. Okay. Next point is reduces the effect of noise. How? The noise is an unwanted signal, as I have told you in the first slide, that enters the communication system via the communication channel and interferes with the transmitted signal. Now, a message signal cannot travel for a long distance because of its low strength, low signal strength. Now, addition of external noise will further reduces the signal strength of a message signal. And so in order to send this that message signal to a long distance, we need to increase the signal strength of the message signal. Now this can be achieved by using the modulation technique. Okay, so here the lower energy or lower frequency matches signal is mixed with the higher energy or higher frequency carrier signal to produce a new signal which has higher energy or higher frequency. Okay, so that it carries the information to a long distance without getting affected by the external noise. And the last point, which is very important because it reduces the height of antenna. Okay, so when the transmission of a signal occurs over free space, the transmitting antenna radiates the signal out and receiving antenna receives it. Now, in order to effectively transmit and receive the signal, the antenna height should be approximately equal to the wavelength of the signal that is to be transmitted. Here, I have taken an example like wavelength that is equals to velocity by frequency. Suppose RF wave has been considered and the velocity of that wave is considered as 3 into 10 to the power 8 per second divided by frequency. Suppose the frequency is given as normal baseband audio signal frequencies, which is from 20 hertz to 20 kilohertz. So 20 kilohertz has been assumed. So if you calculate it, the wavelength is in 15,000 meters. Okay, and the antenna of this height is practically it is impossible. It is impossible. Okay, so that's why what you need to do here at the last, in this last line, I have considered to mixed up certain amount of very high frequency is to be incorporated into this modulated signal. Okay, into this message signal, so that your antenna height will be 1.5 meter, and the antenna of this height is easily uh, to construct. It is easy to construct. Okay, so that's why in modulation process, using modulation process, you can reduce the height of this antenna. Okay, so clear up to this much? Do you have any doubt, any queries? Clear up to this much?
Yes, sir.
Okay. So proceed to the next section where a simple block diagram has given, where I have already told you that the information signal, which is also called the baseband signal, is to be mixed up or multiplied with this carrier signal, and this the device which is used to multiply these two signals is called the modulator. And after modulating these two signal, one modulated signal is generated, which is transmitted over this through this RF amplifier, and uh, it is to be transmitted. Okay. Now the types of signals, I have used these terms: message signal, carrier signal, modulated signal. Okay. So what are these signals? Now, the message signal, which contains a message to be transmitted to the destination. Okay, so this is also known as modulating signal. This is also known as modulating signal or baseband signal. So, message signal can be called as modulating signal or baseband signal. So, don't confuse with these terms. Okay, the original frequency range of a transmission signal is called the baseband signal. The message signal or baseband signal undergoes a process called modulation before it gets transmitted over the communication channel, and hence the message signal is known as modulating signal. Clear? The carrier signal, this is uh, the high energy or high frequency signal which has characteristics like amplitude, frequency and phase but contains no information is called a carrier signal. Now it is also simply referred to as a carrier. Carrier signal that is used to carry the message signal from transmitter and it is transmitted to the receiving side. Okay, transmitted from transmitter to receiver. The carrier signal is also sometimes referred to as an empty signal because it contains no information. The modulated signal, it is used when the message signal is mixed with the carrier signal, a new signal is generated. Now this new signal is known as a modulated signal. That the modulated signal is the combination of the carrier signal and the modulating signal or message signal or baseband signal. Okay, so these are the different types of signals. These are used in modulation process. Next is the type of modulation. The modulation classification. So basically modulation is classified into two types: analog modulation and digital modulation. So under analog modulation there are amplitude modulation, frequency modulation, phase modulation and pulse modulation, and under digital modulation only pulse code modulation is there. So briefly introduced every like most of these three terms. Okay, amplitude, frequency and phase. So analog modulation, what happened? The analog signal or sinusoidal signal is used as a carrier signal that modulates the analog message signal. The characteristics of the carrier signal, characteristics means the amplitude, frequency and phase of the carrier signal is varied in accordance with the amplitude of the message signal. Okay. Now, in amplitude modulation technique, where this kind of modulation, where the amplitude of the carrier signal is changed, it is varied and in accordance with the amplitude of the message signal, while the frequency and phase of the carrier signal remains constant. Okay, only amplitude is varied. Frequency and phase will be same. It will be remain constant. Okay, in case of frequency modulation, where the frequency of the carrier signal is varied, it is changed in accordance with the amplitude of the message signal, while the amplitude of and phase of the carrier signal remains constant. Only frequency is changed. In case of phase modulation, where the phase of the carrier signal is changed or it is varied in accordance with the amplitude of the message signal, while the amplitude and amplitude of carrier signal remains constant. Okay. So here one thing I need to tell you, that in phase of the carrier signal is varied in accordance with the instant amplitude of the message signal in phase modulation. Okay, so when phase is changed, it also affects the frequency. It also affects the frequency. So this modulation also comes under frequency modulation actually. Okay, the frequency and phase modulation comes under angle modulation. Angle modulation, when the frequency or phase of the carrier signal is varied or changed in according with the amplitude of the message signal, then it is called the angle modulation also. Angle modulation. So frequency and phase, these modulation techniques are called angle modulation also. Okay. And now this pulse, in this pulse modulation technique, what happened in the carrier, now in amplitude, frequency, or in phase modulation, what happened, the carrier and message signals are continuous signals, sinusoidal signals. However, in analog, this type of pulse modulation technique, the carrier signal is a discontinuous signal. Okay, it's a series of pulses, and message signal is a continuous signal which is in form of sinusoidal signal. Now analog pulse modulation, it is the process of changing the characteristics. Which characteristics? Pulse amplitude characteristics, pulse width, or pulse position. Okay, these can be changed, these can be varied. Okay, so if carrier pulse amplitude or pulse width or pulse position can be changed in accordance with the amplitude of the message signal, then it is called the pulse modulation technique. The different pulse modulation techniques are available, like pulse amplitude modulation, or PAM, PAM in short, or pulse width modulation, PWM, or pulse position modulation. So different modulation techniques are available. We will discuss it in later, in coming days. So in digital modulation, what happened, it in this technique, this is employed for efficient communication purpose, and the main advantage of having this type of technique is it includes high noise immunity. Okay, and available bandwidth, and the permissible power. High bandwidth is there, and power will be high. And also in digital modulation, the modulating signal or message signal is converted from analog to digital. Analog to digital. So in pulse code modulation technique, which is under this category, digital modulation, the here in this method, it is used to convert an analog signal into a digital signal in 1 and 0s form. Okay, as the resulted signal is a coded pulse train, that's why it is called the pulse code modulation technique. Okay, so this is the classification of modulation technique. Another the pulse code, different types of modulation techniques are available. We will discuss it later. Some terminology can be used here. The first one is the modulation index. Okay, What is it? It is the ratio of amplitude of the message signal AM to the amplitude of the carrier signal AC. So AM by AC is called the modulation index. Okay, and the percentage is this one. Another is the deviation ratio, which is the worst case modulation index and is equal to the maximum peak frequency deviation divided by the maximum modulating signal frequency. Okay, that is called the deviation ratio. So, okay, clear up to this much? Any doubts? Any queries? Okay, so proceed to the next one. Okay, if it is ended by 1 minute, then all of you must join with using the same link. Okay, for the continuation of second session. So start with this amplitude modulation. So it's a type of modulation. So it is a type of modulation where the amplitude or the signal strength of the carrier signal is varied in accordance with the amplitude of the message signal. Okay, as I have told you earlier. So basically, or it can be said as the amplitude modulation is a type of modulation where the information, the message signal, is transmitted over a carrier wave by varying its amplitude in accordance